This is Expert IQ channel. You are welcome to my channel. Please don't forget to visit my YouTube channel. Subscribe to it. Press on the notification bell. Anytime I bring out a new video, you get something to watch. And please don't forget to like the video. Don't forget to like the video. As for today, I'm going to take you through motion. Motion, a very interesting and powerful topic in physics. For my scenarios to students, a very powerful topic in physics. Your lovely maths teacher. Lovely maths teacher. As for today, we are learning motion. Like I said to you, motion. Repeat after me, motion. Less than 10 minutes, I'll let you understand what motion is. My objectives within this period, is to tell you what motion is, define motion, basic parameters of motion, we look at types of motion, and equations of motion. And we take some examples. Let's get started. So now, my objective within this period is to define motion to you, tell you what motion is, explain for you what motion is. I'll let you understand what motion is. I'll teach you some basic parameters and key terminologies in motion, some types of motion, and I'll take you through equation of motion, and I'll take certain examples for us to solve together. Some basic examples. So now, if I say motion, what is motion? What is motion? In the comment section, just write and define in your own way how do you understand motion, but I'll explain to you what motion is. When I say motion, it's self-explanatory. Motion is the change in position of an object in respect to time. And I want you to take note of this. Throughout the lesson, I'll be using something like small triangle. This is what we call change. So now, what did I say? I said motion is a change in position of an object with respect to time. All what I'm saying is that, let me say I have an object A, and I want to move this object A to point B. It needs what we call motion. Are we okay? What we call motion, because this is my initial point, and this object has been able to move to this point. What it has done is called motion, and you know it has covered something. What it covers is what we call distance. During the movement of this object, we consider speed. Is it slow? Is it moving fast? That is what we call speed. And the straight path that this point has taken out to this point, we call it displacement. Are we okay? Displacement. Now, we can consider something with respect to speed or displacement. We can have what we call velocity. So now, as for velocity, is defined as the speed per time of that moving object. Please, are you okay? Now, we can also consider acceleration. This is defined as the change in velocity with respect to time. Are we okay? So these are the basic parameters I said I will take you through. So let's look at them one after the other. We have distance. When we say distance, what do you mean by distance? Distance is just the total path taken by this object to move from point A to point B. Are we okay? When we talk about the speed is calculated at the distance taken per time. Speed. Let's talk about speed. Speed is calculated as the distance covered per time. Let's look at displacement. Displacement is also known as a scalar quantity. Distance is a scalar quantity. So displacement is just the total straight line path covered by this point to be able to move. Are we okay? So let's look at velocity. Velocity is the change in displacement, is the displacement of the object in respect to time. That is the total straight line path covered by this object to move from point A to point B. Let's look at acceleration. Acceleration is the rate of velocity per time. Are you okay? Velocity per time. Please, hope you understand these parameters. Hope you understand it. If you don't understand any, please come to the comment section, comment on it. I'll explain further for you to understand. But I think I broke this down into the simple and a basic way you can easily understand it. Let's look at the types of motion. There are various types of motion, but I'll be considering only 4. Let's look at only 4. Let's look at circular motion. Circular motion. This is a motion along a circular path. This is the motion of an object along a circular path. Example, the Earth orbiting around the Sun. Do you want to get? 2. Linear motion. Please, are you okay? Keep joining. Linear motion. This is the motion. This is the motion taken by an object in a straight line. An object in a straight line. Example, a moving vehicle. What I'm saying is that a moving vehicle cannot move in a circular motion. So one of the basic examples of linear motion is a moving vehicle. 3. Oscillatory motion. Oscillatory motion, please, it's double L. Oscillatory motion. This type of motion is the back and forth of movement of an object, or the to and fro movement of an object. The to and fro or back and forth movement. Back and forth movement of an object. Of an object. Example, a pendulum. Example, a pendulum. Please, are you following? Pendulum. The last one I'll take you through is rotational motion. Rotational motion. Rotational motion. This is a type of motion in which an object moves around its own axis. This is the type of motion in which an object moves on its own axis. Example, a rotational fan. Your own ceiling fan, rotational fan. A ceiling fan moving on its own axis is a good example of rotational motion. Please, are we okay? So now, for the past 1 minute, I've been taking you through the types of motion. I've defined what circular motion to you, and I've explained to you what circular motion is. What I said is that this is a type of motion of an object moving along a circular path. Example, the Earth orbiting around the sun. Let me say there are 9 planets. The planet keep orbiting around other planets. So, for example, the Earth keep orbiting around the sun. That is why we get day and night. The basic explanation of why we get day and night is the movement of the Earth. Are we okay? The second one is linear motion. This is a type of motion taken by an object in a straight line. For example, an object moving from point A to point B, a moving vehicle, is an example of a linear motion. The third one is oscillatory motion. Oscillatory motion. Oscillation motion is just the to and fro movement of an object. For example, if I hang an object on top and a pendulum on top, and I decide to dangle it, the back and forth movement of that pendulum is what we call oscillatory. Are we okay? We have a rotational motion. Rotational motion. When an object begins to spin on its axis, it's what we call rotational motion. Rotational motion. Please, are we okay? That is what I use the ceiling fan as an example. When the fan keep, moving on its own axis, that is what we call rotational motion. Please, are we okay? Let's look at the relation between these parameters of the parameters of motion. Relation between the parameters of motion. And now, before we start this, I just want to define each parameter by a variable. Let's define the velocity to be equal to v, acceleration to be equal to a, distance to be equal to x, displacement should be equal to s. And let's also say velocity, acceleration, distance, displacement. Let's say speed should be also be equal to speed. We can represent speed by capital X. Are we okay? So now we are going to look at the relationship between all these parameters. And I told you that acceleration that we know is the same thing as change in velocity all over time. Hope you are getting me. And change in velocity is also defined as final velocity minus initial velocity. So this will be equal to, let's represent our final velocity to be v, our initial velocity to be u all over t. So this implies that E is equal to v minus u all over t. Let's try this into a linear equation. By crossing multiply, we get at to be equal to v minus u. We can get v to be equal to u plus at. And this is known as the first equation of motion. And looking at the equation simple, you can see that this equation is able to relate both initial and final velocity, acceleration, and time. So now, let's look at the second equation. We are going to drive the second equation. We know that average velocity is equals to speed over, average velocity is the same thing as speed over time. This means that our speed can be equals to average velocity multiplying by t. But we know that average velocity is equals to final velocity plus initial velocity all over 2. This will imply that our s is equals to v plus u all over 2 multiplying by t. But from our equation 1, we know v to be equals to u plus at. So substitute this into the equation. This will imply our s is equals to v, which is u plus at plus u all over 2 multiplying by t. Let's break this into linear form. Implies s will be equal to 2u all over 2 plus half at multiplying by t. This will cancel this. Implies our s can be equal to ut plus half at squared. And this is known as the second equation of motion. Second equation of motion. Let's look at the final and the last equation of motion. The final and the last equation of motion. We said from here, we know our x is equals to v plus u all over 2 multiplying by t. First, we make v the subject and just substitute. Let's make t the subject and put it inside the equation. So from equation 1, v, which is equal to u plus at, will imply that our t will be equal to v minus u all over a. Let's substitute this into x. This will imply our s will be equals to v plus u all over 2 multiplying bracket open. Wherever you see t, you put v minus u all over a. This will imply our s is equal to, this multiplying by this is the same thing as difference of two squares. So you get v squared minus u squared all over 2a. This implies, let's cross multiply and change it to linear equation. You get 2as will be equal to v squared minus u squared. This will imply our v squared is equals to u squared plus 2as. And this is known as the third equation of motion. Please, are you okay? This is known as the third equation of motion. In other senses, we can use graphical way to solve this